Okay, so in this lecture we are starting from here. So we have to find the graph of xt and st is given. Yes, so we have to find the value of yt at the point t equal to 4 and the value of yt at point t equal to zero point 0.5. Okay, so how we find these values? So yt is the conjugate of xt and st, and yt is equal to infinity minus integration minus infinity to infinity x tau h t minus tau d tau. Okay, so we make the graph of h tau. Okay, we make the graph of h tau. We can simply copy this graph here because uh, replacing the variable t with tau will not change the nature of the graph. But now we have to make the graph of h t minus tau. So we taking the first one where the value of t is 4. We have to make the graph of h4 minus tau. So how are we going to make that? First, copy this whole graph like this, okay, and just write minus 1 here and replace the variable t with tau. This is the first step. So I use this software. This is the first step, okay. Now in the second step, we fold the graph. Okay, we fold the graph. So when we fold the graph would look like this, like this one. Okay, so this is after we have folded the graph, and now there is a shifting. There is a shifting of graph of 4. This is a graph of h minus tau. Okay, this is minus. Now let's use this here. Sorry for that sound. Because in this software, pencil is not there. Yes, so we have already covered the two steps. So the third step will be, let me draw the second step again. This is second. Let me change it. So this is the second step that we have done. Folding the graph, so we get the graph like this. One. This is the graph of h minus tau. So what is the last step? We shift this graph by 4. This is positive 4. So we shift this graph to the positive right. Okay. We have already have doubts like, for example, there is a graph xt and we have to make graph xt minus 2. Okay. So we shift the graph ht to rightwards because it is negative. And if we have to make a graph of ht plus 2, so we shift the graph of xt by 2 units backwards. But there is a change that our variable is negative. So all the properties that we are using here when the variable is positive will be reversed. Okay. So if there is a positive shifting, then we do shift the graph to the positive rather than backwards. Okay, what is that? This is variable. So now we shift the graph by 4. So we get graph at if this, and this is the graph of h4 minus tau. So Okay. Now, when we have made this graph h tau and we have made this graph h4 minus tau, so we now do multiply this, as we all know that in the formula minus infinity to infinity h x tau h t minus tau d tau. We do multiply these both terms. We are multiplying these both graphs. Then after multiplying we get this common part. If from 5 to 6 1 amplitude, and at t equal to 4 the value is 1. And now moving to the second part. Now you all know how to make a graph. Okay, how you will make the graph of h 0.5 minus tau. First we have what we do. We make the graph of h tau. We make the graph of h tau. We, we make the graph of h tau, and then we fold the graph, and then we shift the graph to right towards 0.5. And when you multiply the both graphs x tau and st minus tau, this is the resultant. And at t equal to 0.5, the value that we get is 5.5. T equal to 0.5, the value we get is 5.5. Now we go to this second question. So here we have given xt is e power tau u minus t. St is given this. So we know the graph of xt. We make it like this. You know graph of e to power tau. It is like, so when you multiply it by u minus t, when you multiply it by u minus t, you will get only the negative part. Okay, and this xt graph is simple, so we make that. Now if we take the conjugate of both of these, so the main thing in convolution is that to find a convolution, both xt and xt have some same time period. If they don't have some same time period, then we cannot find the convolution of that function yt. It is not possible. So as you can see here, xt having a range of minus infinity to 0, st having a range of 0 to 2. So there is no intersection time period between both of them. So we cannot find the resultant, and hence at at t equal to 4, yt is 0. Now, now discrete time LTI system. Okay, everything is same. The case is that it is discrete now. So del n is hn in discrete. Del n minus k is hn minus k in discrete. Everything is same. Nothing change much. Okay. Del x power minus x minus 1 del n plus 1. LTI. Unit impulse response of BTS system. Mathematical representation. This is sigma x k del n minus k. So due to the property the value of k is n, so we put the value of k is equal to n, but it became a constant, so we take it outside. Now this value is 1. because it is the range is crossing the impulse. So xn is, so this is the proofing. This is the same in the time domain. This is the formula that we have already covered, and in the discrete domain the integration is changed by summation, and there is a different variable k. These are some standard results. As we all know that if we take a conjugate of any function with ln, then the function itself will be the answer. If we take the convolution of any function with un, then now in the time domain we get running integration of that function, and in discrete domain we get the running summable of that function. Running summable means sigma, because it is summable, and it's infinity, which is fixed. It is fixed, and two ends. So this is variable. This here is variable. So you have to remember these, both of these terms. These two are only the that we have to remember, most basic. Now this is the first question. So 1 by 2 power n un conjugate un. So they both have the same time period, and as we all know, if you take the conjugate of any function with un, it will give the running summable of that function. So this is the function here, and now sigma k is equal to k minus infinity to 1 upon 2 power k uk. So now in this we have variable tau, and in discrete we have variable k and n minus k. This is k uk. Now due to this uk, the limits is changed to 0 to n, and now we get uh, okay, this is 1 minus a upon 1 minus half. Okay, now so get to know how we write this. Okay, now so now moving to the second question. uh, Half power n un conjugate un minus 3 is equal to yn. So first we have to mark the range of this conjugate. Okay, if you see, uh, this 1 by 2 power half is just like a graph like this: 1 by 2, 1 by minus 1 by 2, 1 by 2, 1 by 2, 1. It's a graph like this. Okay, after multiplying with u, like only 1 by 2, 1 by 2, is all 1 by 2. This is the graph of that, and un minus 3, you all know that. So its range is 0 to infinity, and this range is 3 to infinity. So the common area is 3 to infinity. Okay, so now we consider this yn, this whole term, to be zn. Zn is equal to half power n un conjugate un. Okay, so this is a formula of infinite gp 1 in a upon 1 minus. So this here is a. Okay, this is 1 This is our r 1 by 2. So if you put values of k in it, so if you put 0, 1 plus, now we write the whole formula. It will be okay. What we are doing here is uh, as we know that if you multiply any function, if we take the conjugate of any function with un, then we get the running summable of that function. Okay, so due to that fact, we make a new function zn which is not shifted by this three three units. Okay, so first we find this term which is not shifted by 3 units, and then we shift the result of Zn by 3 units, because the relation between Yn and Zn is Yn is equal to Zn minus 3. So we get the integration, not the integration, we get the running summable of 1/2 power n un. We already know from the previous question, this one, that we get the result like this, and now we shift this result with 3 units. So now we get the result of yn. So we have to think like that to solve our question, to make it simpler. If we go to the long method, it will take a lot of time, but a little bit of trick, we can solve it very quickly. Okay, so this is the long term, I think. While solving by methods of running integration, running summable, don't forget to attach limits. We have should always attach limits while solving for running summable and running integration. These are the standard results that we have to remember. Conjugate of del n with del n is del n. It's just similar to time domain. All the properties are similar like that are in time domain. So if we take a conjugate of del n minus n1 to del n minus n2, then we all know del n will be the answer and the shifting will add it. So it is minus n1 and minus n2. So if we take the conjugate of any function with del n, then we get that function as the result. We all know that. We are not wasting time here. Okay, now this is important one. The sixth one, un plus alpha conjugate un plus beta. Okay, so now un will give the integration of un. It is ramp function, so we write it like that, and the shifting will be added. So it is n plus alpha plus beta, and there is a plus 1 in it. Okay, so there is a plus 1 in it. Okay, this is the formula. See, if you take conjugate of un with un, we'll get the running summable of un sigma minus infinity to n uk. It will give us r n plus 1. So we can write like n un. So n plus 1 un plus 1. Okay. So now this term is more this term here can also be written like this. In Hindi it is called retain. I can talk in English here. Retain outside n and subtract 1 from the inside n. Okay? In Hindi it is called बाहर वाले n को रहने दो और अंदर वाले n को माइनस कर दो 1 यूनिट से. ठीक है. So we can write this term like this by retaining the n outside and subtracting 1 unit from the inside n. So now if we take the convolution of this un plus alpha conjugate un plus beta, it will, we all know it will give us ramp function, and we all know the shifting will be added. So we add n plus alpha plus beta, but it will also give us extra 1. How we know we get this extra 1 from here? This. Okay. From here we know that if we take the running summable of un, we get un, we get rn plus 1. So do remember that this 1 is extra here. Okay? This 1 is extra here. We have to remember that. Take color green, this one. Now I think yes. So I should mark this. Un plus alpha conjugate un plus beta will give us rn plus alpha plus beta. We can also write that r n un. So we can also write like this n un. So we write n plus beta. Okay. We write like n plus beta plus alpha plus 1 n un. N plus beta plus alpha plus 1 un plus beta plus alpha plus 1. Now retain the 1 from the outside and subtract 1 unit from the inside. So we can write like this. Sorry for the sound. Now method of discrete convolution. Either x1 or this. So now what are the methods of discrete time convolution? So if the duration is infinite, then we use this formula. Okay, un sigma k is minus infinity to infinity xk h and minus k. It is just similar to the time duration. Okay. Now, yeah, but if both x and h are finite duration, then we use a tabular form. So method based by using standard method, timeline method. So I've told you about this how you can make the graph of this hn minus k. A graph of hk versus k, fold that minus, then right shift that by n. Simple. Vary n and calculate summation. This is the first question. First of all, while solving any variable summable and summable question, so we have to ensure the range of the function. The range of this is minus 0 to infinity, and this is hn This is our hn, and the variable here is minus, okay, and the breakpoint here is p, and our variable is minus. So the limit is from minus infinity to that breakpoint. It is minus infinity to 3. So the common part here is this infinity, 0 to infinity. Okay. Okay. तो अब वापस से आते हैं, कहाँ पे था मैं? Okay. So if you look into this new question, follow my cursor. Is it recording? Okay. Xn is given as nun and hn is given as also nun. So the range of nun is 0 to infinity. So their resultant range is also from 0 to infinity. Okay. And this is the basic formula. This is the basic formula. Okay. And now we write the equation for k sk. Okay, that is for greater than k it is values k and else it is 0. And now we have to write the equation for h and minus k. Okay, so it is like n minus k un minus k. Okay, now okay, तो हाँ ठीक है, तो ये देख रहा था मैं, सबसे पहले इसकी ब्राइटनेस कम करो यार. So this was the question that we are solving, and we reached, I think, here. So we make the equation of xk where for greater than k the value is k and else is 0. And now we have to make the equation for hn minus k, which is given as nun. So we replace n with n minus k. So n minus k un minus k. Now here we can see that uh, n is equal to k and our variable is k, which is negative. So it is from minus infinity to n, its value is n minus k and else is 0. So now we make the graphical representation of both of these two functions. So if we make xk, it is k for k greater than equal to 0. So from 0 it is, for greater than 0 it is k, and for else it is 0, means less than k. And for hn minus k it is n minus k for minus infinity to n. So from minus infinity to n it is n minus k, but we do not know that this n is less than 0 or greater than 0. Okay, so it is discrete. So we cannot say just n is less than 0. We have to, okay, so uh, so we do not know that n is less than 0 or greater than 0, but it is discrete function, discrete time. So we cannot say just n is less than 0. We have to say n is less than equal to minus 1. Okay, because fraction values are not allowed in discrete. So in the case 1 where we let that n is less than 0, it means that in discrete function, in discrete time, n is less than equal to minus 1. So this is the basic equation for conjugate for yeah, yeah, convolution. Yeah, convolution. So yn, this is yn is equal to sigma k minus infinity to infinity xk h n minus k is equal to 0. So now it is 0. Why it is 0? Because we have to multiply both of these. And what is the common area in both of these when n is less than 0? So focus on my cursor from minus infinity to n. This is the graph of hn minus k, and the graph of hk is from 0 to k. So if you multiply both of these, this graph from minus infinity to n will multiply. Let me use that. This graph right here will multiply by this value, which is 0, and this graph right here will multiply by this, which is for now it is 0. Okay, because our graph is from minus infinity to here also. So in case number 1, the value we get is 0. Okay. uh, in the second case, in which we have assumed that n is greater than equal to 0, so in that case we write our resultant as yn is equal to sigma k is equal to 0 to n k n minus k. So focus our graphical representation of h n minus k is from minus infinity to n, which is greater than 0, and our sk graph is just like that. So if we multiply both of the graph, so we get a common area if we match the common point, which is 0, and this is the common area, and this graph here will multiply by 0, it will be removed. So the resultant graph is like this from 0 to n, and the value is k. Okay, so this is the equation for the graph 0 k is equal to 0 to n for k n minus k. Okay, okay. If you multiply both of them, it will be, it is not n, it is not 1. I thought it was 1. So if it is n minus k, then k into n minus k will be the amplitude of the resultant graph, and the limits are from 0 to n. Okay, now uh, you have to know these, sorry, you have to know these formulas. Okay, this is the sum of natural numbers, and this is the sum of natural number in square: 1 square, 2 square, 3 square, 4 square. So if it simply adding the natural number, then the formula is n plus 1 by 2. Okay, n plus 1 by 2, and if it is adding the natural number with the square, then n plus 1, 2n plus 1 by 6. Okay, so we have multiplied this k to n and this n. Then first term we got nk and minus this k square, so it is nk. So n is constant, so we take it outside, and this k is like, this is just like this addition. We write n plus 1 by 2. Okay, and this k square is like 1 square, 2 square, 3 square, then the addition of natural number with square. So this is the formula for this, which is n plus 1, 2n plus 1 by 6. So if we do not know these formulas, we cannot get the end result. So we have to remember these formulas. Okay, brightness. So now when you solve this, you will get a result like this. And if you write the final answer, you can write like if n is less than equal to -1, then the result is 0. And if n is greater than equal to 0, then the result is n square minus 1 by 6. Okay? Now when so now this is given as a question y n is equal to a n u n conjugate b n u n. So here this this graph is like this. This a power n power n. We are taking conjugate of these two graphs. So the resultant range of this function is 0 to infinity. Now we write the basic formula of conjugate. The first term n is replaced by k and the second term is replaced by n minus k. We write like this. Now as we know, we then multiply. We take ak and this b minus k common. If bn is constant, so we take it outside. Now this uk un minus k. Okay, this is this range is from 0 to infinity and its range is from k to this. Okay, our variable is k, so it is 0 to infinity, and here the for this variable is k, so it is minus sign, and the break point is n. So our range is from minus infinity to n. Okay, no, like this. So that is discrete. Okay. So it is minus infinity to n, and because of this uk, it is 0 to infinity. The resultant range is from 0 to n. 0 to n. So Bn sigma k is equal to 0 to n a by b power k. This is the result. Now let's go to this question. So if you see, when you see ut term is attached, when you see the ut term is attached, when in both the coefficient of t is same, when you see the coefficient of t is same in both the cases and ut is attached, then directly apply the formula. So we directly apply the formula here. Yeah, okay. So if when ut is attached and when we see that the coefficient of t is same in both the cases, and so we can directly apply the formula. It will be way easier. So we directly apply the formula here. So it is in time domain, okay? And the resultant range is also from 0 to infinity. So We simply write the basic formula, that is this minus infinity to infinity e की e की power a tau u tau e की power b t minus tau u t minus tau d tau. So now this bt, see my cursor, we take it out, it is constant. Okay, now this minus term, now we can write e की power a tau divided by e की power b tau from here, and this u tau and u t minus tau multiplied. So the range of this ut is from 0 to infinity, and this ut minus tau is from minus infinity to t. Because of this term, the resultant range will be from 0 to t. This is e dt e की power bt integration 0 to t e power at upon e power a tau divided by e power b tau. E, e to note convolution integral as long as sign of t is same. Convolution as long as sign of n is same. Convolution integral. Question based on tabulation. Tabulation is used when the time domain is finite. We have given xn and hn. So xn is given 5 minus 1 2 4, in which the origin is at 2, and hn is given as 1 2 3, in which origin is at 2. So just like a discrete time function in the time domain series, we can write xn as function of impulse function like this. Amplitude is 5, okay, and it is at, this is 0, this is minus 1, this is minus 2. So del n plus 2, because it is minus 2, and for this minus 1 we write minus 1 del n plus 1. For this 2, 2 del n, and for this 4 plus 4 del n minus 1. Just like that, this hn also, it is 0, this is minus 1. So 1 del is minus 1. So 1 del n plus 1, 2 del n plus 3 del n minus 1. So now we have done n del u. Okay, this 5u n plus 1 minus 6u n plus 1 plus 3un. So this is 0. Present minus previous, 5 un plus 2 plus 2, so it is minus 2. So minus 1 minus 5 minus 6 un plus 1. So this one 0, 2 minus minus plus 3, and for this 4. So we can write this discrete function like this, as I told you now, and we can also write this discrete function in the form of step function. So the basic of this discrete function to write in the form of step function is, first write like 0, make even, okay, From 0, left side and right side the number of elements should be same. So we write 5 and also add 0 both side. Also add 0 both side. 0, 5, this one, 2, 4. So now for writing this first one, take this present value, present minus previous. Okay. So sorry for this. This present value we have to write for write it like here 5, 4. So for this 5 and 0 is adds 2. We take this 5 minus previous, so it is 5. So we write 5, 2, and plus 2. And for this 0, for this is 0, this one, this is minus 2. So this minus 1 done. We take this minus 1 minus 5 to minus 6, 2, and plus 1. Okay. Now for this 2, it is as 0. So 2 minus 3, so it is plus 3. So plus 3, q, n. And for this 4, 4, 4 minus 2, so it is 2 plus 2, q, n minus 1. And for this 0, we write plus, will not plus, minus q. So this is the equation. I hope you understand that. The basic is uh, present minus previous. And similarly, we can write for HN also. Now, Xn is this. Okay. We can, these are the different matters. This is 1, 2, and this is the most usual. This is 3. Okay. Simply mark the points. Okay. And then make a tab table. Write Xn elements here and Hn elements here. And divide it like this. Okay. Now, this is the first term. Now, take sum of them and write it here. Take sum of this diagonal, write it here. Take sum of this diagonal, so 8 minus 3. Okay. Take sum, so 8 minus 6, 8, sorry, 8 plus 6, 40, and this is 12. So this is the resultant answer that we required. We also see this xn length. Remember this formula. Remember this formula. This length of x is 4, for 1, 2, 3, 4. Length of hn is 3, because only 3 terms. And length of yn is 4 plus 3 minus 1 will give us 6. Then, so this summation of xn is 10 and the summation of hn is 6. So if we take multiplication, then we get 60. Summation of, also remember this also, this, and also if we have summation of x in terms is 10, h in terms is 6, and summation of resultant is multiplication of it. So here the summation of this minus is 4, 4 plus 6, 6, 10, 3, 6, 60. So if you multiply this, we get 9, 5, 14, 29, 24, 4, 4, 8, 10, 48, 8, 2, 50, 50, 10, 60. This sum is 60. Satisfy condition. Now, now we have importance of equation tabulation. So, what is case 1 and case 2? So, this new concept, if the question asks that what is the value of y and at n is equal to a. So, okay. So, in this question, see this question. Hn is given as 1 by 2 power n un and xn is a causal signal. Okay, is it recording? Okay. So we have left at this question. Okay. So in this question, Hn is given as 1 by 2 power half un and xn is a causal signal. Okay. Now this, as we know that the resultant yn is a convolution of xn and hn, and the value of y at 0 is equal to 1. The value of y at x is equal to 1 is half, and it is asking for the value of x at 1. So in this type of question, what we do, that if the question asks for x at 1, so we make, okay, and in this type of question, if the question is asking for at x is equal to 1, so we make the table till hn h1 and x1. If the question is asking for x is equal to 1, so we make the table till x1 and h1. Okay, and if the question is asking for x4, so we make the table till x4 and h4. Okay. Okay, and if the question is asking for x is equal to 4, then we make the table till x is equal to 4 and h4. Okay, too much. Okay, so now moving to the question. So the question is asking for at x1. So we make the table till x1. Okay, it is x0, x1, and x3. So it is not the table for this question, I think. No, it is. In this question, we make the table till x3, but we do not necessarily make the table till x3 because uh, we can have the answer for this question till here, till x1 and h1. So you write x values of x on the horizontal axis and the values of h on the vertical axis, and then multiply them and then divide this table diagonally, as you can see in this. Okay, now see, this y0 is x0. Okay, this y0 is x0 h0. This y1 is x0 x0 plus x1 h naught. Okay, so we have given the value of y0. We write y0 1 here, and x0 into, and we also have given the value of h0. uh, no, okay, y0 y1 x1. Okay, okay, this means when y0 is equal to 1, and now uh, as we know that we have given the value of y0. Okay, and y0 is x0 into h0. So y0 value is 1. Okay, and we can find the value of sh0 from this given equation. So if we put the value 0 at n is equal to 0, then we get h0 equal to 1. Okay, so we put this one value in this equation and we get the value of x0, that is 1. Okay, now we put the value of h0 and h0 in the second equation. Okay, and we have also given the value of y1, that is 1 by 2. Okay, so this y1 by 2 and this x0 is 1, h1 is 1 by 2. Also we can find it from here by putting 1. Okay, and then we have to find this value x1, and this h0 is 1. So from here we get the value of x1 as 0. So that's how we solve this type of question. For example, in this question, uh, question okay, okay, so the question has given us the value of n from 0, 1 and 2. Okay, now he is asking for y3 and y4. Okay, okay, so in this question we have to find the value of y3 and y4. So we have to make the table till x4 and h4. Okay, but we have not shown the table in here because it is too lengthy to solve in this class. So you can do this in your home, okay, as your homework. but we crack the pattern and we solve it anyhow. So till here, this y2, we know that we sum all of these terms, okay, x0 h2 plus x1 h1 plus x2 h0. Okay, now we find the value of this x0 is 1, okay, this is 2h1, this is x0, which comes out to be 4. We have given the value, we can use the given values and we can find it. It is very simple question. And what is y3? So this is a pattern. As you can see, this is 0, this is h2, 2. This is 1, this is 2. h1, 1. Okay, but it's kind of not a pattern. I already knew that. So you have to make the table. Otherwise, you cannot solve this question. But it will not take much time to solve this question if you have the practice to make the table very quickly, which is very easy. Okay. Okay. Now moving forward, now we uh, get to this new topic, which is the property of LTI system. Okay. Now, okay. Okay. So is the properties of LTI system. Okay. So the first property is causality of an LTI system. See this. This is an causal system. Why? Because the output is depend on the past value of input. As we have studied earlier, the output should depend on the present and past value of input. Then it is a causal system. And see this also. This is true. This is also true. It is depend on the present value, and it is depend on the past value. This is past, and this is present. And see this one. It is a non-causal system. System. How? Because it is 2 and it is 4. So the output depend on the future of the input. See this equation, it is a convolution equation. So it has a condition. If the t is less than tau, if this t is less than tau, so this become past and this becomes future. So this system will behave as non-causal system. And if this t is greater than tau, then this became past and this became future and this became past. So it will behave as a causal system. Okay, behave as a causal system. So the main condition that we have to remember for our examination, okay, that is an LTI system is to be designed in such a way that it's always a causal system. How? This see this equation. This is a convolution equation. So as we have discussed earlier here, that if the t is greater than tau, then it is causal. If t is less than tau, then it is non-causal. Okay. Now, so now we are here. Okay, and an LTI system is to be designed in such a way that always causal system. Okay, as we have uh, discussed this earlier, that this is a basic formula of convolution. Okay? And if this is in this if this yt term wants to be a causal system, then this t should be greater than or equal to tau. And if t is not greater than or equal to tau, if it is less than tau, then it is non-causal system. Okay? So the causal system is obvious if the desirable condition, non-desirable condition, and non-convolution is non-desirable condition. Okay, okay. So this is the condition that we got. Okay. So for an LTI system to be causal system, So the main result that we should remember is this here. It is written that an LTI system is to be causal system if its unit impulse response, that is HT and HN, must be a causal signal. So the statement is saying that if we want our LTI system to be a causal system, then its impulse response, that is HT in the time domain and HN in the discrete domain, it should be a causal signal. So it is a signal. Okay. In formula, this is the condition that HT is 0 for t less than 0 and HN is 0 for n less than 0, means in discrete n is less than or equal to -1. Okay. Okay. So now I hope you remember this of this one. Yeah. So if a LTI system is to be a causal system, then the impulse response ST and or HN should be a causal signal. So these are the examples, and we have to find that which LTI system represent a causal system. So these are given the impulse response. Okay? So A is not a causal system because ST is not a causal system. This is also not a. Okay, no, it is causal. Why? Because if you see this, it is H minus T. So ST will be look like ST will be look like, okay, it is not. ST will be look like this, okay. This ST is a causal system. So this is a causal system. This is a causal signal. This impulse response is a causal signal. So that's why this system is a causal system. Okay. Now this is also a causal system because ST is given and it is on the positive side of the time axis. This is not an causal system, so it is also not a causal system. It is not a causal signal, so it is also not a causal system. Okay. Uh, yes. So what we have to see here, always check for HT. Okay. Because this was a tricky question. At first, I think it is not causal signal, but it was because the coefficient of t was negative. So we have to check that coefficient of t is positive, and if it is not positive, so we should make it positive and then apply the concept to check the causality of the signal. Okay. Now moving on. Now this comes the second property of LTI system, that is the stability. So how to check a LTI system is stable? Okay. Now read this. Okay. For an LTI system to be stable system, every possible input bounded, every possible bounded input, bounded output will be obtained only when ST is absolutely integrable. So if you remember this, absolutely integrable is a condition when the modulus, if you take the modulus of integration of the modulus of the function and it comes out to be finite, then the function is absolutely integrable. Okay. So this we already discussed earlier. Okay. Do you remember this condition? Do you remember these all steps we do to check the for bounded input and bounded output for stable system? We have already discussed all of this term earlier, so please go through my lecture I've discussed in lecture number 1. So go see lecture number 1. Okay. So now this is a condition of absolutely integrable. Okay. Function is absolutely integrable. Okay. So if this is finite, then st is a energy signal, as we all know, and if it is infinite, then st is a power signal. Okay. If the integration of the modulus is finite, because we all know that finite signal are energy signal. Okay. So now is this the integration? This is a condition for absolutely integrable. If it is finite, then it is energy signal, and as as you all know that energy signal, all the finite signal are energy signal. Okay, and if it is infinite, okay, if this integration is infinite, it is a power signal. So st is energy signal. This means that its duration is finite, so it means that st is absolutely integrable, but vice versa, it may be true or may not be true. Okay? For example, impulse function. It is non-energy function, not power function, but its area is finite, so it is absolutely integrable function. And this function, as you know, the in time domain, coefficient, some of the coefficient is 0, so it is finite duration, finite amplitude, so it is energy signal. Okay, so now so it is energy signal, and because it is an energy signal, so it is absolutely integrable, so that's why it is stable. So our LTI system is stable. As you can see, this impulse response, it's not a causal signal, it's not a causal signal, so that's why this is a non-causal system. So these question determine the stability of the following LTI system having unit impulse response. So the first one is we discuss is the impulse function. So it is stable LTI system plus it is causal LTI system also. So this term exponential. So this graph comes out to be like this. Yes. So it is a stable system. This is the graph. Okay. So it is a stable system. Okay, because at time t is equal to infinity, its value is constant. Okay, so it is finite. Okay, and this is stable LTI system, and it is causal because it is starting after 0 and before 0 the function is 0. St is sin t. So sin t is a periodic function, and all the periodic functions are power signal. Okay? All the periodic functions are power signal. So LTI system is unstable. Okay, because it is a power signal. It is not energy signal, so it is unstable, and it is non-causal because the graph of the graph of sine is like, so it is also before 0. Now this exponential, okay, where I can draw it. Wait a minute. It is blurred. Let me delete all this. Okay. So now we are drawing the graph of this. So if we only draw the graph of e power 2t, it is like this, 2, but we multiply it by this. So okay. So now it's like only this. So it is also an energy signal because at time t is equal to infinity, the value is constant. Okay. So the LTI system is constant and it is anti-causal because why? Because at t is greater than 0, the function is 0, and at t less than 0, no. The only condition for anti-causal system is that at t greater than 0, the function should be 0. Now this from you can see the our variable is negative, so and the breakpoint comes out to be 2. So the range is minus infinity to 2. So minus infinity to 2. So our graph will look like this. 2. So uh, it is a stable system because here it is stable and at t is equal to infinity here at t is equal to infinity the value is constant and saying okay, so at t is equal to infinity the value is constant and yeah, it's stable and it is non-causal because it is also the value of this graph is also before t less than 0. Okay, so this is the concept of envelope. So if you see uh, function like this, that is there is a function and there is a multiplication of sinusoidal signal sin cos t, especially cos t or sin t, anything. So first draw the ft in reference form and take the mirror image of it. Okay, then calculate xt at t is equal to 0 and then draw the sinusoidal shape between them. What I am saying? So see this question. So there is a constant a and there is a sinusoidal cos omega t. So we draw the graph of a, that is this dotted line, constant value, and then we take the mirror image of this dotted line, that is this, and then in between we draw the graph of cos omega t. Okay, now we draw graph of cos omega t in between the envelope. Okay, so if we want to draw the graph of this function, so you can see there is a t, there is a function, and there is also multiplication of this sinusoidal signal, that is cos t omega t. So here the function is t cos t, it is t ut, t ut into cos omega t. To make the graph of t ut, this should look like this. Okay, it's the same graph of y is equal to x. Okay, and then we take the mirror image of it Then we take a mirror image of it here, and then in between we draw the sinusoidal costing. Another example, this is the function ft. This is ft here, and this is the sinusoidal signal. Okay, so we written like this. Now we draw the graph of e power t, e power minus t ut, just like this. See my cursor, which is like this. Okay, and then we take the mirror image. Okay, take its mirror image. Always remember, take its mirror image. Now, in between we draw the sinusoidal curve. In this case, that is sine t. So as you can see, it is stable because at t is equal to infinity. It is constant. Constant. Okay. Now this is given. So our function here is t multiplication e power minus at and ut. So now we have to remember that the graph of t e power minus at ut is look like this. First increase, then decrease. Like a torque slip character, kind of a torque slip characteristic graph in induction motor. Quite similar to that, but it's not because it is open at the end. Okay, so that's how you can relate this graph with torque slip characteristic in induction motor, which was like, no, it's not. Oh, it's can't draw right now. Okay, now tracing done. So if you want, we want to draw the graph of this function. This, you change the color first. I think this blue one is okay. So in the above question, we already draw the graph of t into e power minus at. Okay, but now here it is multiplied by ut. So, so the graph is like this. So first we draw the graph of this function, that is t into e power minus at, which should look like this, and it is ut. So all the graph that is before the zero is zero. We assume it to be zero. Then we take a mirror image of it. It should look like this. Okay. Then we make a sinusoidal sine t in between this graph. It will look like this. Okay. The drawing is not good. We can understand the topic. Okay. Moving on. Okay. Now, for a discrete time system to be stable, every bounded input output must be bounded. Okay? The unit impulse response Hn must be absolutely summable. Okay, similar to the time function that we have studied earlier, that a function, a LTI function is stable when the impulse response is is okay. In the time domain, if the integration of the modulus of the function is finite, then the entire system is stable because the integration of the modulus of that function tells about the function that it is absolutely integrable, an absolutely integrable function having finite duration. Finite duration signals are stable. Now, in discrete function, this integration is replaced by this sigma function that is summable. So, if in discrete function we want our LTR system to be stable, so our unit impulse response Hn should be absolutely summable. So the condition of absolutely summable is that summation k is equal to minus infinity to infinity modulus hk, okay, which comes out to be finite. So here is the conclusion. If this function system, which is sigma k is equal to minus infinity to infinity modulus hk, so if it comes out to be finite, then Hn is energy signal, and if it is comes out to be infinite, then Hn is power signal, and also it could be a non-energy non-power signal. Okay? So this condition, if Hn is absolutely summable, then Hn is a energy signal, and if Hn is an energy signal, then vice versa also true that Hn is absolutely summable. Okay, okay, so this is the causality of determine the causality and stability of following a discrete time LTI system. So this is the question that we have given, that Hn is 2 power n un. So this is the graph of Hn. Okay? So it is a causal signal, as you can see that the graph before t is equal to 0 is do not exist, and it is absolutely summable. Okay, it is not absolutely summable, as you can see. This graph is keep on increasing, and it is keep increasing up to infinity, so there is not a finite duration. Okay, so it is unstable system. Okay, so the first term is causal system, and it is unstable. Now this one, this is minus 2 power n un. When it is positive, it is when it is 0, it is 1. When it is 1, it is minus 2. When it is 2, it is 4. And when it is 3, when it is 3, then it is minus 8, and so on. Okay, so we have made the graph of this Hn, and by looking at this graph, we concluded that it is a causal signaling system. Why? Because this unit impulse response is a causal system, is a causal signal. Why it is a causal signal? Because at t less than equal to 0, there is no graph. Okay, the whole graph starts from t is equal to 0. Okay, but it is unstable. Why it is unstable? Because, sorry for the sound. Why it is unstable? Because it is keep on increasing. There is no stop. It is keep on increasing like that up to infinity. So that's why it is an unstable system. Okay. So if a question is given like this in the second example, that it is 2 power n u3 minus n. So here we can see that our variable is minus n. Okay. So the breakpoint is that, or breakpoint is, okay, 3. Okay. 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 It is minus, so it is minus infinity to 3. Okay. So what does, okay, so our range here is minus infinity to 3. Okay. So if it is greater than 3, then our function is 0, which we have shown here. If it is greater than 3, then it is 0, and a discrete function greater than 3 means it is greater than and equal to 4. Okay. And if it is less than 3, that is from minus infinity to 3, this graph exists. Okay? And it is 2 power n. 2 power n. So we have made the graph of unit impulse response, and now by looking at the graph, we can find out that if it is causal, anti-causal, or stable or unstable. Okay, so now as you can see, this graph keep on increasing up to infinity. Okay, but at t is equal to infinity, the value is constant. Okay, this graph is not constant because at t is equal to infinity, its value keep also increasing. Its value is not constant. Okay, and in this question, at t is equal to infinity, the value is constant. Okay, keeps on decreasing, so it is reaches tends to 0, and it is finite finite duration. It acts like a finite duration graph. So it is an energy signal. So it is a stable signal, stable system, because our Hn is a stable signal. That's why whole function is stable system. Okay.